So in this video, we're going to be discussing how do we evaluate functions using function notation. So last class we talked about what function notation was, and we talked about that f of x equals y. So if I'm talking about a point, basically what you have is a point, you have x and you have f of x. So we're basically replacing our y with a fancier way of just saying f of x because x has only one y value for it, in this case for a function. Okay, so now let's talk about okay, if I'm given a rule, which a lot of times we're given a rule where you only get one x value, one y value out of it every single time you plug in an x. Well, we can figure out what that y value is by using the rule and basically plugging in. Okay, so in this case, I need to evaluate f of -4. So the x that I am plugging in here, if this is like a table, is -4. And I'm trying to figure out what is my f of x. So what is my output? So we're going to use our rule and plug it in. And so we have -4 squared plus 3 times -4. When you're squaring a number, you want to be careful because what you're doing is you're doing -4 times -4. Well, -4 times -4 is a positive 16. Every single time you square a number, it is a positive number. Now 3 times -4 is -12. And now we can go ahead and combine these and put them together. So 16 minus 12, and we have 4. And so whenever I plug in a -4, I get out of 4. So f of -4 equals 4. All right, now in this next example, we have just a slightly more complex function here with fractions, but they're asking us what if f of -2 equals m, what's the value of m? So again, they gave us the value of x, the input, we're trying to figure out the output. So we need to plug in a -2 wherever we see an x, compute this, and figure out what the y value is. So I have 1/3 plus 1/3 times -2 over 4. And then here I have -2 over 4 times 2/5 minus 1 over 6. All right, so first what we want to do is we want to do a multiplication. So up here, the 2 over 3 doesn't simplify, and 1/4 doesn't simplify, so we're just going to go ahead and multiply this straight across. So 1/3 plus, again, it's not a plus anymore because I'm multiplying a positive times a negative, and so I'm going to get -2 over 12. And then down here, I honestly would, before I even go on to that, I would simplify the 2 over 12 to a 1/6 and get my final answer as 1/6. So yes, 2 over 12 is going to simplify to 1 over 6. And then here, the 2 over 4 is going to simplify to 1/2. And then the 2 over 2 simplifies here to 1 and 1. So really what we have is -1 times 1 and 1 times 5. So this becomes a -1/5 minus 1 over 6. So yes, there was a lot of simplifying that happened there. Let's kind of go back and just discuss that before we do it. So first of all, what I did was we simplified this fraction here. We simplified it to the original fraction to -1/2. And then we simplified across. And so this became 1 and this became 1. And then we multiplied straight across. So -1 times 1 is -1. And 1 times 5 is 5. So we had a -1/5 here, minus 1/6. Now what we need to do is up here we need to subtract this and get a common denominator, and we need to subtract here and get a common denominator. So the greatest common denominator, the least common denominator between 3 and 6 is going to be 18. So what we're going to do is we're going to multiply this by 6 over 6 and this by 3 over 3 so that we can get a common denominator. And so what we're going to have is 16 over 18, 6 over 18 minus 3 over 18. And so up here in my numerator, I have 6 minus 3 is 3, so 3 over 18. On my denominator here, the least common denominator is 30, so I'm going to multiply this by 6 over 6, and this by 5 over 5. And so on my numerator, I have negative 6 over 30. And on the second fraction, I'm going to have negative 5 over 30. And so I'm going to have here negative 11 over 30. So my first fraction, let's go ahead and simplify that. 3 over 18, it simplifies, 3 goes into 3 once and into 18 6 times. So let's simplify that to 1 over 6. And now the way that we're going to divide our fractions is we're going to do keep, change, flip. So you keep the first and multiply by the reciprocal of the second. So multiply by negative 30 over 11. So just notice that reciprocal doesn't mean that signs are changing. So now here, 30 and 6, that simplifies to 5 over 1. And so when I multiply straight across, I get 1 times negative 5, which is negative 5 over 11. So my output here would be negative 5 over 11. Okay, now here, this next example, we have that f of x equals 5x plus 2, so we have our rule. They're saying if f of m equals 12, what's the value of m? So this is slightly different because they're giving us the output of this function. And we need to go backwards and find the input. So what we're going to do here is, well, we know what it's supposed to equal, right? And we need to find x. So this should feel very familiar. How could I solve for x? Well, yes, what we were doing in the past unit. We need to go ahead and solve for x by doing inverse operations. So right now we're multiplying x by 5 and then adding 2. So we're going to subtract 2 from both sides to get rid of the plus 2. We get 5x equals 10, and then we're going to divide both sides by 5 to get rid of the multiplying by 5, and so x is equal to 2. And so that means if I plug in a 2, I'm going to get out a 12. Well, let's check. If I plug in a 2 here, I get 10 plus 2 gives me 12. So yes, the value of m is 2. Oh, give me 1 second. So the value of m is 2. All right. Now, the last example here, this is more of something where you will see in the future. It's called a composition of two functions. So what I'm doing is I'm inputting an algebraic expression inside of it. So my input is z minus 1. So obviously, if I'm plugging in an algebraic expression, I'm going to get an algebraic expression on the outside. So if my input has a z in it, your output's going to have a z in it, and that's okay. So we're going to do the same thing we were doing if this was a number. Wherever I see an x, I am putting in z minus 1. So make sure you put parentheses so that you make sure you capture both z and the minus 1. And then now we're going to go ahead and just simplify this answer. So first I would distribute, and I have negative 3z, and negative 3 times negative 1 is positive 3 plus 1, and then combine like terms. So I get an output of 3z plus 4. So that means if you plug in a number minus 1, you're going to get an output of negative 3 times that number plus 4 every single time. So it's just kind of like a rule for it. So I hope that you found this video useful on how to evaluate using function notation.